Alright, problem number 1 says you're given 5 tiles, each with a digit printed on it. And you have the tiles 2, 5, 5, 7, and 8. And the question asks, how many ways can you arrange these tiles using each tile once to form a 5-digit number that is divisible by 6? So, my hint to you would be to remember your divisibility rules. And in order for a number to be divisible by 6, then it has to be divisible by 2 and 3, right? And in order for a number to be divisible by 2, the number has to be even. And in order for it to be even, the last number has to be even, right? So the last digit has to be an even number, which limits us to 2 and 8, right? So those are our only options for the last number. And in order to be divisible by 3, the sum of the digits have to add up to a number that's divisible by 3. So you can see that 2 plus 5 plus 5, that's 12, plus 15, 7 plus 8 is 15. That gives us 27, which is a number that's divisible by 3. So really any combination of these, should I say permutation of these digits, is going to be divisible by 3. But not all of them are going to be divisible by 2, because only the numbers ending in 2 and 8 are going to be divisible by 2. So that's the hint I would have. And so go ahead and stop the video if you want to and work some more on it. Otherwise I'll go ahead and give you the solution. So I'm going to give you the solution here. Now there's a number of different ways, as usual, to work this problem. One is just to systematically list out all of the numbers, all the different arrangements of the numbers, and then just count them up. Now, I don't think you want to sit here and watch me come up with all of those. So what I've done is I've already done that, and I'm going to see if I can paste those in here. Let me see. Here we go. Alright, let me scroll down. Alright, so what I've done here is that I've already come up with all of the combinations of these numbers. And you can see there's two cases. There's the numbers ending in 8 and the numbers ending in 2. And then, basically within those two cases, I looked at, all the ones starting with 2, 5, 2, 7, there's only one because of the double 5, 5, 5, 5, 7, 5, 2, 7, 2, 7, 5. And then for the numbers ending in 2, I looked at, 5, 5, the one starting with 5, 5, 5, 7, 5, 8, 7, 5, 7, 8, 8, 5, and 8, 7. Okay, so I just sort of systematically typed them all in. So that's one way you could do it. And if you count those all up, you get 24. Okay, that's one way to do it. So that's the answer, is 24. But let me try to show you a different way to do it that'll make your life easier. And I really want to post some lessons on combinations and permutations and counting, sets of things without actually having to count them all. So what I'm going to do here is I'm going to first of all look at the two cases. So there's case 1, I'm just going to say are numbers ending in 8, how about? Okay, and then if we place the 8, then we've got 4 digits left, and let's pretend that all the numbers are different. Okay, So, well, they're not different, obviously, because we have two 5s. But we'll worry about that later. What I want to do is look at the permutations of 4 numbers. So if we were to place the remaining 4 numbers, we've already placed the 5th number. So you'd have 4 choices for the first one, 3 choices for the second, 2 choices for the third, and 1 choice for the last one. Okay, that would be, that would be assuming that the 2 5s were were different. Okay, but they're not different. So this permutation here would assume that let's say we have maybe I'll just use a different color here. I'm going to use, we can have let's say we have a red 5, and let's say we have a green 5. Okay, and then a 7. Okay, so it's going to assume that this 2557 is different from this. Well, actually, let me back to there. This 2557. Okay. All right, because the permutation assumes that all of these numbers are different. Okay, but they're not. These 5s are really the same thing. So for every set of 4 numbers that we choose, we're going to get 2 permutations. Okay, but those 2 are really the same. So what we have to do is divide that by 2. And if we do that, let's just cancel all this stuff out here. We'll get 12. Okay, and that's just the case for the numbers ending in 8. And we can also look at the case, let's say case 2 is those numbers that are ending in 2. Okay, but it'll be the same thing really, because you can see over here we still have the 2 5s, and we got 4 digits to choose from, so we'll basically get the same thing. We'll get 4 choices for the first one, 3 choices for the second one, 2 choices for the third, and 1 choice for the last one. And then we have to divide out the duplicates because it's going to assume that those 2 5s are different. And we're going to get double the numbers, so we have to divide it by 2 to take into account the fact that the 2 5s are really the same. So again, we get 12. Okay, and if we add those up, we get 24. All right, so that can make your life easier. You can also think of this, another way to do it is to say, work with all 5 numbers, and let's just place the last digit first. So we have 2 choices for the last digit, for the 5th digit, and then we can place the rest of them, the rest of the digits. So we'd have 4 choices for the first, 3 choices for the second, and 2 choices for the third, and 1 choice for the 4th digit. Okay, so we've actually placed, this is actually the 5th digit right here. All right, and then this is the first, second, third, and 4th. Okay, and again we have to take into account that the 2 5s are the same, so we have to divide by 2 because there's 2 ways to arrange those 5s, and they're both the same. So we can get 24 this way too, more directly. Okay, so there you go. There's the way to do it, and I'll be posting some more counting lessons to cover combinations and permutations with repeated elements and things like that in the future. So be looking for those.